Okay, let's do a few more Poisson examples. Okay, so let's imagine that you're working at a service counter, maybe at your job. Okay, you're taking in returns. Okay, you work at the customer service place. Typically, when someone asks you how many returns do you see in a half hour, or how many customers do you see in a half hour, you say, well, mostly, on average, I see 9 customers every 30 minutes. Okay, assume the number of customers served is a random variable x. Hopefully you know then, given this rate, okay, average of this per that, you should know that this is probably dealing with a Poisson distribution. So what's the probability that exactly 10 will come in a half an hour? Okay, so we expect 9, but of course other options are possible. Okay, so here x is the number of customers in terms of 30-minute periods, and we usually expect 9 per 30 minutes. So x is a Poisson where the expected number is 9. So what's the probability of exactly 10? Here is the probability distribution for a Poisson. E to lambda. Lambda here is 9, so e to negative 9. Lambda to the power of x here. So lambda is 9, and here we're trying to see exactly 10, so it would be 9 to 10 all over x factorial. Again, x here is set to be 10 over 10 factorial. You can do this calculation in your calculator or use Minitab. This is calc probability distribution Poisson. Here, I want the equal sign, okay? So I want x is exactly equal to 10, so I'll click the first option, probability. The average number is 9, and I'm trying to figure out what's the chance that I get 10. Okay, here you can see the probability is somewhere around 12% chance that 10 people will come, not 9. B says, what's the probability of at least 3? Okay, well, first of all, you expect 9, so at least 3 you, first of all, should think would be very, very high. Okay, so we expect 9, at least 3. You can map this out. You could have 0 customers in a half an hour, 1 or 2, 3, 4, or anywhere up to theoretically infinite amount of customers that come in. Okay, so at least 3, so that's 3 or more. Of course, let's look at the complement so that we can find the less than or equal to sign. This is 1 minus less than or equal to 2. You could calculate this using your probability distribution if you like. This is 1 minus exactly 0 minus exactly 1 minus exactly 2. That would be written in this format if you wanted to do it. Or, of course, I can use Minitab to find this cumulative probability by going calc probability distribution. This is the Poisson distribution. Here I've got less than or equal to 2. Okay, where I expect 9, the probability of less than or equal to 2 is given here. So we're looking for at least 3, so 1 minus at most 2 gives us the probability of at least 3. Okay, again, our intuition said it should be high, and it is. Okay, what about 5 customers in 15 minutes? Again, this is when we need to re-parameterize this distribution. We're given a rate in terms of 30-minute chunks, half hours or 30-minute chunks, but we want to talk now about 15-minute chunks. Okay, so here what I'm going to do is, originally I say that's 9 customers per 30 minutes. If I do 9 divided by 30, I'll get that's 0.3 customers per minute that I expect. And here I'm going to multiply my unit, okay, which is in terms of just 1 minute. I want 15 minutes, so I'll take this 0.3 and I'll multiply it by 15. 15 times 0.3, I expect 4.5 customers per 15 minutes. The other way, of course, you could think about this is I get 9 in 30 minutes, and 15 is half of 30 minutes, so I could divide 9 by 2 to get 4.5 customers per 15 minutes, if you like that way as well. Okay, what's the probability of exactly 5 in 15 minutes? Exactly 5 then will be y is equal to 5, and here you could write it out using the distribution. Here we've got a new lambda, which is 4.5, so it's e to the negative 4.5. 4.5 to the power here, 5, all divided by 5 factorial. Or in Minitab, then we can just go probability distribution. This is a Poisson. Our rate now has changed to 4.5, seeing as we're talking about 15-minute chunks and not half an hour chunks. And we want the exact probability of 5 customers coming in 15 minutes. You can see here somewhere around 17% chance.